everybody, welcome to the first video of my new channel, Synthetics Aura. Today we will be discovering the hidden mysteries of the Monty Hall problem, made by the Canadian television host Monty Hall. Well, duh. The Monty Hall problem is now incorporated into schools worldwide. It is used in grades 4 to 7 to uncover probability with a fun example. As you can see here, we have our game show. So let's begin. Imagine this. You're on a game show. 3 doors stand in front of you. Behind one door is a shiny new car, vroom! And behind the other 2, goats. You don't know which one hides what, but you really want the car, right? So you pick one. Let's say you pick door 1. At this point, your odds of having chosen the car are 1 in 3. The other 2 doors together carry a 2/3 chance of hiding the car. Now, the host, who knows everything about that's behind the doors, which is our little creepy guy over here, opens one of the remaining doors and reveals a goat. So let's say you pick door 1, and our little guest guy over here reveals door number 3 as having goats. So here's a twist. The host always reveals a goat. Now you're left with your original choice, door 1, and the other unopened door. The host asks, do you want to stick with your choice or switch to the other door? So either you can switch to door 2 or you can stay with door 1. But door 3 is the revealed door with the goat. At first, your gut might scream, it's 50-50 now, it doesn't matter. But here's the thing, our intuition is lying. The Monty Hall problem is a classic example of how probability can feel completely wrong. Let's break it down. You initially picked door 1, 1/3 chance of winning the car. That means 2/3 chance that the car is behind one of the other doors. When the host opens door 3 revealing a goat, those 2/3 don't disappear. Instead, all that probability shifts to the remaining unopened door. Switching gives you a 2/3 chance of winning, and sticking gives you a 1/3 chance. In short, switching doubles your chance of driving away in that sweet car. Let's make it a bit more visual. Imagine you're picking doors with candy instead of cars. One candy is chocolate, the others are carrots. Gross, I know. You pick door 1. Host opens door 3 and shows a carrot. Should you switch? If you switch, you get the chocolate 2/3 of the time. If you stay, you get it only 1/3 of the time. Your stomach thanks you for switching. Okay, mini simulation time. Grab 3 cards, cups, or even flip your favorite Pokemon cards. Pick one at random, your first choice. Have a friend reveal a losing option. Play 2 rounds. First, always stick. Second, always switch. Keep track. You'll notice a pattern. Sticking wins maybe 3 out of 10 times, but switching wins 7 out of 10. This is why you should always switch. Boom, instant probability lesson in action. Okay, let's do a few more examples for fun. Imagine the car is behind door 2 this time. You pick door 1. Host opens door 3, goat revealed. Switch to door 2 equals win. Another round, car behind door 3. You pick door 1. Host opens door 2, goat revealed. Switch to door 3, win again. If you repeat this a dozen times, switching wins way more. So yeah, it's not a guaranteed win, but it is a more likely chance. Even more crazy, try thinking in extremes. Imagine 100 doors instead of 3. 1 car, 99 goats. You pick door 1. The host opens 98 other doors, all showing goats. Now only 2 doors remain, your original pick and 1 unopened door. Would you like to stick with your only 1% chance? Of course not. You switch, and suddenly your odds shoot to 99%. That's Monty Hall on steroids. It's easier to see the logic in this bigger scenario, which is why it seems so mind-blowing with only 3 doors. Why does this feel so weird? Because psychology time, our brains are lazy. We see two doors and our intuition thinks 50-50, but it ignores the fact that the host action isn't random. The host knows where the car is and will always reveal a ghost. That knowledge gives you extra information and probabilities shift accordingly. Here's a little joke to keep things fun. Why don't goats play the games you show? Because they always lose. That doesn't make any sense. I found that on Google. Dad joke. But you, if you switch, can win. So the next time you face the Monty Hall problem, remember, your first choice is unlikely to be right, and switching gives you the better odds. It's a classic reminder that probability can be counterintuitive, and intuition alone isn't enough to win every time. Try this with friends or family. Make it a game night challenge, like Monty Hall did. Who can win the car, or chocolate, or the candy more often? It's fun, simple, and it makes math stick in a way that's way more memorable than numbers on a page. Monty Hall is more than just a game show puzzle. It's a lesson in logic, probability, why we should sometimes trust math over instinct. Stick, 1/3 chance. Switch, 2/3 chance. Remember that, and maybe next time you're in a similar scenario, you'll make the smart choice. Thank you, and have a great day, and don't forget to subscribe to Synthetics Aura.